Alrighty, good afternoon. So my name is Kai, and I come from New Zealand. I grew up in Germany, and at some point decided to escape the lovely lands of this country and move to the other end of the world, where I work self-employed with my own small company, doing a variety of different things. Apart from Android and particularly Kotlin, I'm really a big fan of Nintendo video games, so if anyone plays Pokemon or has a 3DS or something like that, come and see me afterwards to talk about that kind of stuff. Also, if you want to, you can tweet me questions or feedback or whatever you want during the talk, and I'll get back to you afterwards. So, Webview, one of the misunderstood components of the Android SDK, really. A lot of people hate the Webview because it gets abused by people all over the place. And the one thing to mention here is phone gap. Let's take a website and wrap it into the Webview. So let's have a look at what the Webview can actually do and where it's good and where it's actually not that good to be used. So what we'll talk about today, we'll have a look at the fundamentals of the Webview, where it comes from, what it actually is, and what its heritage is. And that's kind of important, I feel, because you can't really build on top of something if you don't know what exactly it is, really. Then we'll look at the typical architecture patterns for Webview-based apps. And what we'll find there is there are 2 or 3 common approaches to use it or to abuse it, unfortunately, as well. Then we'll talk about how to use the Webview in your Android projects. That's actually reasonably straightforward. And we'll look at some typical problems and challenges. And that will be an interesting topic to talk about because you can't even stop talking about problems and challenges when it comes to the Webview. It's actually a tricky thing to build an app with web technology in kind of another layer, leaving the Android framework. And finally, we'll look at some other things, for example, what happens with the Webview in Android 8 and yada, yada, yada. So some fundamentals for a start. So what is the Webview? First, it's part of the Android SDK. That's easy and straightforward, right? So it's a thing, in this case, a view component that displays web pages. And what that basically means, it uses a thing, an HTML rendering engine, usually, to display HTML pages, web pages, inside our Android app. And when you think about that, you quite quickly come to the realization that the Webview is really a browser. It's kind of a browser running in your Android app. And that causes a lot of the issues that we're seeing in the wild. Typical use cases. And there are good use cases to just make sure we're on the same page. The best use case for the Webview, from my point of view, is you use it as a component, right? You have HTML formatted content, for example, help content, some articles, pre-formatted data you're getting from a database somewhere that comes as HTML, and you basically want to show that in your app. The Webview is perfect for that. And it's much nicer to do it in a Webview than actually opening Chrome or whatever browser from your application. There's another technology in that area which is called Chrome Custom Tabs. They are really good for content as well, but they actually don't give you full control of the Chrome, of the look and feel of that content inside of your app. The second typical use case is people build individual views of their app inside a Webview instance. So it might be that you have an HTML form anyway, and you want to use that inside of your app, so you put it into a Webview component, and that's one screen or one activity of your native app. And that's a fair use case. Where it gets problematic is if people decide to build a complete app in web technologies, wrap it into a Webview, and basically ship that out as an Android app or as an iOS app for the same reason. The interesting thing is that can still be done, and there are tons of bridging technologies that help with that. Like PhoneGap or, for example, React Native. They all work in a similar way, basically. And then the worst use case is take your mobile website as it is and wrap it into an Android app just because you can. that usually leads to a substantially worse usability compared to building a native app, for obvious reasons, really, right? At the same point, I want to really stress it's important not to be, those Android developers that are arrogant and basically say the only way to build an Android app is a native app. Because what counts at the end is not only our feeling about the purity of our application, it's also what the app does and how much profit it generates. I know Webview apps from people who literally did the last thing. They took their mobile website, wrapped it into a Webview as it is, and that app makes a profit of 50 grand a month. And I know beautiful, material, native apps that make $10 a month, right? So who am I to judge telling people not to wrap their mobile website into a Webview? If it suits their business, that is fair enough. So looking at the Webview and its heritage, it's a really old component. It's been around since forever, literally, in SDK version 1. But it had a lot of iterations over time. And the most well-known and common iteration is probably around Android 4.5 to Android 4.4 to Android 5, when Google decided to replace the Webview with Chrome. In the beginning, though, the Webview was WebKit-based. And everyone who's around in the web technology side of things a little bit knows that WebKit is kind of Apple, Safari, iOS-y, essentially. We'll get to that in a second, basically. One important thing to mention, though, is the Webview in Android 4.3 and earlier is full of really, really bad security holes. So if you, for whatever reason, have a phone that runs Android 4.3 or earlier, please burn it right away, because it's just like ridiculous. Also, if clients want you to support an app or to build an app with the Webview for Android 4.3 or earlier, say no. Just say no. It's like seriously a really bad thing to do. So since KitKat, Android 4.4, Webview is now based on Chrome, respectively Chromium. For the sake of ease, I just continue to say Chrome, but technically it's Chromium, the open source project behind Chrome that we're talking about. In Android 4.4, basically Google said, right, from now on we ship Chrome, and that was Chrome 30. In 4.4.3, it was changed to Chrome 33. So there was an upgrade basically built in. The interesting bit, though, is with Android 5 and Webview or Chrome 36, the model of how you would get new Chrome versions has changed. So up to 4.4, even though it was Chrome, it was baked into the firmware. You couldn't update it yourself. But now, basically, since Android 5, it gets updated separately through the Google Play services. So you get, if you update your apps regularly, you get new versions of Chrome and therefore new versions of the Webview independently of Android updates, which is a really important thing. Then WebKit. WebKit comes from an old project from the KDE guys, a browser and a JavaScript engine called KHTML and KJS. That was developed like since the late 90s, coming out of the whole Linux ecosystem. Apple forked that into a thing called WebCore and JavaScript Core, and that became Safari and was pushed out as Safari on OS X at some point. Then Apple said, like, well, that's not that awesome. Let's change that and upgrade it to WebKit 2. And they built their own custom JS engine, which is now essentially an Apple thing. But from then on, essentially, WebKit was still used for Chrome, for Mac, for Windows, Chrome for iOS, and Chrome for Android. So Google did a similar thing. They forked, essentially, WebKit and built their own technology based on top of that. So initially, they used WebCore, which came out of Apple, but wrote their own JavaScript engine. So we've got Google V8. And then at some point, they separated further and built a thing called Blink. And Blink is the current HTML rendering engine in Chrome and therefore in the Webview since Chrome 28. And apart from Chrome, and all the rendering parts of that, there's lots of other stuff. There's the Android browser. In older versions of Android, that used to be WebKit as well. Then there is the Samsung Internet, which is also based on Chromium, but there are a few versions back, and that's itself that is an issue, basically. And then there are obviously countless other options in the browser and HTML rendering space out there. UC browser, which is incredibly popular in Asia, and it's, trust me, the most shittiest browser I've ever had to work with. It's unbelievable. You can't even debug it properly. And then there's good stuff like Opera and Opera Mini and Firefox and yada yada yada. So today, the Webview though is quite good because it upgrades itself, or it gets upgraded through Google Play, as we talked before. And obviously for that, you need to make sure, or the user need to make sure that they update their apps through Google Play, either automatically or manually. And the weird thing is, sometimes certain phones push for, like Webview or Webview rendering components, and other phones didn't. And I found some interesting data on that, basically. This is from a blog called Quirks Mode. It's from a guy who deals a lot with Chrome and Chromium and Webview and how stuff basically works inside. And he tested certain phones and looked at what happened when he upgraded from 4.4 to 5.0 to respectively Chrome and the Webview. And you see a lot of, the actual numbers don't really matter, but you see a lot of inconsistencies there, which basically means when you do operating system upgrades in around that time, or with older phones, you can get really weird results. The good thing, though, is, in that other table here, what we can see there is that back in September 2016, and that's the latest data I could find for that, a lot of people were running up-to-date versions of Chrome and therefore the Webview. So when you look at that number, you'll see something like 75% of the users were using one of the 3 latest versions of Chromium at the time. And that's reasonably good, given that those Chromium versions are something like 6 to 8 weeks apart. When you try to compare that to the fragmentation we see on the Android operating system, this is like magic, It's like people upgrade and people are up to date. So Webview and Chrome, now it's bundled in the Chrome APK. So there is still a separate Webview, but the vast majority of people on modern phones will just get the Webview component that comes out of the Chrome APK. The cool thing is, if you install the Chrome Dev or Beta or Canary channels, like have multiple versions of Chrome, you can actually use them as your Webview rendering engine. So I'll show you that in a second in the developer options here. If you switch your phone into developer mode, do the 7 times tapping thing, you have an option to set the Webview implementation now, which basically means if you want to test your Webview-based app with what is coming in 2 or 3 versions in Chrome, you can do that kind of stuff now, depending on how far forward you want to go. Another interesting thing you can do with modern Webview is multi-process Webview. And that was recently added in Android 7, I think. Essentially what it does is it increases the stability and the security of your Webview-based apps, because it means that there will be multiple instances and multiple processes of your Webview across different apps, or even inside the same app. And you can keep things separate. Unfortunately, that's currently a developer option, so it hasn't made its way into mainstream Android, and people have to manually enable that. And the reason for that is basically because it increases the startup time slightly, so it makes your application startup a little bit slower, and that's why they've decided not to put that into the mainstream setup. Let's have a quick look at some of the architectural approaches people go with. And that's where things easily get ugly. So first thing is, we use the Webview as a regular UI component. So you build your Android app as you always would with native views, but where it makes sense, where you have HTML content, you use a Webview. Perfect, right? That's like the intended use of the Webview, why people back then put that component into the Android framework, because they wanted a way to render HTML. So it's a simple way to do all that kind of stuff. There are hardly any cons at all. It's just fine. You can, go ahead with that. Typical example, and with, I have to say one word about the drawings. I had actually really nice diagrams, with Visio kind of boxes and stuff. And then on Sunday, I started sketchnoting after the Barcamp talk, and I decided to rip all my diagrams out and draw them by hand. So you might or might not like that, but I just needed to get practice for sketchnoting. So here, we'll see essentially on the left-hand side, just an activity with a list. On the right-hand side, kind of a detail view. And that's all native. There might be a recycler view and basically another screen. You tap on a list item, you end up on a detail page. And that bottom section, about me, that might be a web view because we pull that from a database and it's maybe pre-rendered HTML content. Right? That's the normal intended use of the web view, why it was built. The next step is WebView as UI containers. So let's say your application's UI is now defined in HTML and CSS. Because maybe you're a web developer or your team has a bunch of web developers who have nothing to do at the moment. So someone says, that's an awesome idea, let's design a UI in HTML and CSS. And that's fine at that point, right? But what it means is you end up with one of two possible scenarios. The first one is your application logic, like the business and the data logic, is still in native code. And you would, for example, say, there is some sort of an interfacing layer between my web view, the UI, and actually the rest of the app. And for example, if you want to branch out to a server, your API calls would still be done through Android, native code. You get some data back, and you pass that back into your web view to render some HTML template. The other option is basically you do pretty much everything in the web view. So you say, like, I hold all my business and data logic in JavaScript. That's what you would naturally use for that. My API calls are done with basically Ajax out of my web view with web technologies. And that interface between your web view and your native app becomes very thin all of a sudden. Typical pros and cons for that. So the pro is obviously you might be faster to market because it's actually, from experience, usually easier to build a web UI than to build a full-blown native app for a lot of people. And there seems to be a scarcity of Android developers, but a huge pool of web developers. And that's realistically what clients and teams sometimes look at. So you have like better availability of resources and potentially a lower cost. The problem is that works for a start, but it can become very complex, and it's not trivial at all. You might run into performance problems. You might run into some more complex technical challenges. From like a diagram point of view, on the left-hand side, we see that scenario one. So what we have there is basically a web view that holds the whole UI inside of the app, and there is some sort of a form with a submit button. And what would happen in that scenario is I would basically, as a user, click the submit button. The web view would tell the app, hey, someone clicked something here, you have to do something, through that JavaScript interface. Then the application would say, all right, I need to send some data or get some data or do whatever I need to do. Go back into steps 3 or 4 to the server, get some, let's say, JSON API data back, tell the web view, hey, I've got new data, and instruct the web view to render that. So your web view is like a view, but the application still controls the whole process. The second scenario is the other option in that case, where we basically say, same form, now we submit the form, we run an Ajax call to an endpoint with web technologies, we get some data back, and that would typically be partial HTML, so it would be some HTML fragment, or it might be still some JSON data, and that Ajax call updates the web view, and the app basically is just like a box as a placeholder. And now, last case, web view as a wrapper, which is kind of the worst one. It's very similar to the previous scenario 2, but that JavaScript interface now hardly exists at all, or is not even there at all. Typical scenario is take your mobile website, wrap it in PhoneGap. and off you go. The pros: fast, easy, cheap, if you want to go with that. The cons: user experience not great, and performance might be a massive issue, particularly if your web developers are of the opinion that using stuff like jQuery Mobile or Sencha Touch or all those pre-made UI frameworks for HTML are an awesome idea. Then you pretty much know that the user experience for the end user might not be the greatest solution. From a structural point of view, again, we've got like a form in a web view, and now that submit button is pretty much not even bothering with doing API calls or communication with the app. It's literally submitting an HTTP post to a website, and it's getting a complete new page back, and it renders that page in your web view. So we've got a few options. Now, how do we use the web view in Android? It's, like I said, actually really straightforward to get started. So you take a web view object, you instantiate it, and that basically gives you a basic web browser. Now, the web view is a view, and it can be treated like any other view, more or less. So our code to do that would look something like that. We basically declare it in the XML, and we get back our web view instance. Off we go. Now, the problem with that is, the web view is actually a quite dumb component for a lot of reasons, and mainly around security, right? So your basic web view can literally only load a URL and show that. And if you want to do a bunch of other things and use modern web technologies, you need a thing called web settings. So for example, if you want to have JavaScript or local storage or a web database, all those HTML5 APIs, you need to kind of set it up accordingly. Some examples are here. For example, you basically get the settings object for a start, then you enable JavaScript and you enable DOM storage. DOM storage is basically local storage in your web view. And there are tons of other options. That's why I put the link to the web settings documentation in there, because there are probably 20, 25 functions and little bits and pieces you can enable or disable. But by default, most of it is switched off. Then we have another thing called the Webview client. And that is kind of necessary if you want to start tinkering with navigation and page load behavior in your web view. Typical scenarios why you would want to do that are things like URL overriding and error handling, or SSL error handling. The aspect of URL overriding is really interesting, because by default, the web view will, if you click on a link that it has no idea what to deal with, pop up the activity manager and say like, hey, how do you want to open that link? Obviously, if you are in a web app inside a native Android app, and you tap on a link, the last thing you want to do is allow people to open Opera from your app, right? That would be kind of, rather misleading. So if we want to prevent that, and if we want to make sure that if people tap on links, certain things happen, we need to override the default functionality. And that's in a function called should override URL loading in that WebView client class. So basically what you need to do is you override that function, and here we have two examples depending on API version used, because the function signature has changed at some point. And you need to return true or false. So true basically means the host app will handle that URL, which is your Android app, which by default might mean Activity Manager pops up. False means your web view is supposed to handle that URL. So pretty much for any link that is supposed to stay in your web view, you need to return false from this kind of override. And what you end up doing then is you deal with the common URL schemes you find in your web content. So for example, the first thing you usually come across with weird error message is mail to. Because if you have existing HTML content, it might have email links. But if you tap on a mail to link, what would you want to happen, right? You would probably want the default mail client to open in your, or from your web view-based app. here's how you would do that. So you basically check the URL scheme, you define, hey, that's mail to, you create a new email intent, and you open Gmail or whatever your email client is. Similar thing, telephone URLs. Again, the last thing you want to do is, create an error message or do nothing. You probably want your dialer application to come up that people can actually dial that phone number, right? So you need to catch the tell URL scheme, create a new custom event, a custom intent, and then trigger that to open the dialer app. Similar things happen for a lot of those schemes. So other typical ones are market, to make sure you end up going into the Play Store if you have a market URL. And then at the bottom, or in the middle of this slide, we'll see the checks for HTTP and HTTPS. And basically, what the code in there does is it returns false if the actual host is a certain domain I want to stay in. And that's actually from a live application where a client wanted to pretty much take existing web content into an app. But what you don't want to have happen is if there is a random link to Facebook, let's say, or Twitter, that people open Facebook or Twitter in your app. That would be kind of a weird experience again. So you want to have a check where it says, like, only stay in the web view if it's actually a page from us, whatever that criteria is, and then return false. And the last class that is worth mentioning for this basic setup is the web Chrome client. And that's necessary to interact with the browser UI. So typically, you'll need that if you do stuff like showing a file chooser for document or photo upload from your phone, or interacting with the browser's console to look into error messages popping up there, for example. So from a structural point of view, it looks kind of like that. You've got the view that has Webview as a child, and then a whole bunch of associations like web settings and the Webview and the web Chrome client, and on the left-hand side, the JS interface, which we'll get to in a minute. There are a bunch of other classes worthwhile mentioning, though. If you want to run a web view in a fragment, you need the Webview fragment class. There's a web storage class to deal with all sorts of storage APIs inside of your web view. And there is a set of service worker classes, which are basically JavaScript threads that you can actually use in Chrome to make those available in your web view inside of your Android app. That JavaScript interaction layer that I mentioned a few times before is called the JavaScript interface. And if you want to be able to call JavaScript functions from your Java or Kotlin code, or respectively from JavaScript call functions in the actual host app, that's how you would need to implement that. So you basically say, all right, I'll add one-to-many JavaScript interfaces. I give them a symbolic name like Android or Firebase. And then in JavaScript, I can call functions in that interface that are annotated JavaScript interface from JavaScript. So this register alias function, for example, I could call with android.registerAlliance from JavaScript. The other way is rather ugly. So essentially, if you want to call into JavaScript, you need to do it with a load URL JavaScript, blah, 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 my function. All right, let's have a look at problems and challenges. So in a nutshell, you are building an app on top of another runtime platform, and you will never be able to get full control of that. Never. And that's something you need to accept and realize if you even go down this whole path. Typical issues, you might run into bugs introduced in the web view, or existing bugs just not getting fixed because no one cares enough to fix your problem. You find users not upgrading their web view because they don't upgrade their apps and they're still using Chrome 29, for example. Or they can't because they're stuck on some super old phone they imported from China that doesn't get any updates at all because it doesn't even have Play Store, and there are tons of crazy scenarios. You'll suffer from a lack of insight what happens in the web view, so you might run into error messages you have no bloody hell what exactly they are and how to even find out what they are. And you might run into performance issues compared to a native app. And if I haven't really, totally turned you off even trying that, let's have a look into some details. So with the Webview updates, the assumption for that is kind of you're building one of those apps that has a view in HTML and some kind of business logic or view logic in your Webview as well. So when Webview gets updated by Google through Chrome, you basically jump from n to n+1. But the reality is, people will not be on n+1 right away. People will be on n minus something, depending on how, how large your, or depending on the demographic of your population. So you might have users who are 10 versions back or 3 versions back, and you don't really know that, which will change in Android 8, actually. So you can't rely on users upgrading. Some will never upgrade, and you will get complaints saying, like, this doesn't work, this is slow, this looks weird. That's just what happens occasionally. The good thing, though, is a lot of people do upgrade. And if you deal with a new population of Chrome and Webview users, you will actually get a lot of benefit out of that if you optimize your code. The typical scenario, when we look at breakage, looks like that. In Chrome 48, for example, the behavior of window.inner-width and inner-height has completely changed. So everyone who did something with those DOM fields was pretty much screwed. And you had to work around that quite quickly to make your Webview-based app still work. Or try to use something like TalkBack or other accessibility features in your Webview-based app. Really difficult and not really pleasant. Soft keyboard inside of Webviews, depending on the Chrome version, sometimes overlays UI elements weirdly. And again, all those problems can be solved. They are just not trivial, right? And obviously, when you build Android native apps, there are UI issues as well. Like you upgrade some libraries and frameworks, and all of a sudden, stuff starts to break. So when we look at supported technologies in the Webview, there is a site called caniuse.com, and that will be your best friend quite quickly. It produces tables like that, where you can say, like, hey, I've got different browsers, and I want to use certain HTML and CSS and JavaScript things. Does that work? And that gives you a really good indication of what to expect and what might or might not work. Typically, web developers or Webview developers also use polyfills, which are basically kind of gap fillers for stuff that doesn't exist in a certain version of a browser or a Webview. So it's a bit like mimicking behavior that should be in HTML5 according to the specs, but let's say Chrome 37 doesn't have yet. So you use like a JavaScript library to fill that gap. It's like a shim for browser APIs, essentially. One really nasty issue people ran into with Webviews recently is a SSL certificate issue. So in 2015, Symantec had a massive problem with SSL certificates they created. So they pretty much leaked information, and people got certs for organizations they shouldn't have got. As a result, Google said, you know what? From Chrome 53 on, all Symantec SSL certs have to comply with certificate transparency. Unfortunately, at the same time, there was a bug in Chrome 53 and 54 that broke all the Symantec certificates relying on exactly that feature. So Google required them to comply, and then they pretty much screwed it up in Chrome. But what started to happen then is every Webview-based app where the users had like Chrome 53, 54, started getting error messages saying like, your cert is broken, on every single tab or page request. And the only way to fix that is basically to write Android code, to check the Webview version, and then basically tell the user to go to Google Play and please, for the love of God, update their Webview. And that is really annoying, right? That's really, really annoying. And the funny thing is, we basically, for one of my clients who have an Webview app, we do error tracking. And there are still people, now that Chrome 60 is out, with Webview versions of 53 and 54, so that still happens. So the other problem when you look at a scenario of error tracking and bug tracking is, there are scenarios where you get those kind of crash reports in Google Play. Something breaks in Webview Google APK or in libWebview Chromium SO. And again, at that point, you look at the stack trace, and all you get is something like that. And you're like, what the hell? I have no way to do anything about that. So you Google those error messages, and basically pretty much what the recommendation is, log a bug with Chrome. And that's what you do. And basically give people the app where this happened, and someone is going to look into that. Sometimes I found it can be traced back to certain CSS or certain JavaScript libraries or statements, but it's a massive pain in the neck to kind of fix those bugs. Performance. Webview apps will be slower than native apps, obviously, because you're having another layer in there. And I've seen anything between 5 and 30% from field experience. When you compare like HTML list rendering and recycler view-based list rendering, you get more scheduling delays. You have usually a higher CPU load, and that's kind of the downside for that. You can optimize a lot of things in the Webview app, but it will never come up to the way how a native app behaves. Let's just run quickly through some other things. I mentioned those just passing by. Camera and gallery upload, it works, so you can access the file system and upload photos. Don't try it on Android 4. It's unbelievably broken. Unbelievably broken. It's just unusable, basically. Android 5 and above, it's just fine. On and offline can be tricky with a WebView, because obviously if you have a WebView and you're going out to the web, your phone goes offline, user taps kind of a link, and they get something like that. That really beautiful little Android robot error page. So you have to work around that by having kind of a connectivity change receiver, or implementing on-receive error in your WebView client, but there are ways to deal with that. Just be aware of the problem. Back button is another thing. Back button in a WebView normally takes you back like history back in a browser. But Android's back button behavior might be totally different in a native app. So quite often the result is weird unless you override the WebView's back button behavior with custom logic. And there's a function for that on backpressed where you can deal with all that stuff. And finally, Android 8. So Android 8 introduced one really, really interesting new feature, which is an API to inspect the available WebView. And that's really, really helpful, because what it means is you can now say, does this user come with a phone that has WebView 57 and above? And previously, believe it or not, you couldn't do that, basically. You could just have like semi-intelligent guesses, essentially. It doesn't cause the WebView to load if it isn't yet. And it's a really simple API call. So you basically say, like, get current WebView package, and then you look into what, for example, the version name or the version number is. Third-party solutions we mentioned, PhoneGap and Apache Cordova, they're usually used to wrap websites into native apps. I wouldn't recommend doing that. It's, like I said before, usually not a great user experience. There's another thing that is unfortunately deprecated and dead now. That's called the Crosswalk project. And what that was, and it can still be used, it's a WebView component that you can bundle with your app. So instead of relying what's on the user's phone, you basically get a library and you can ensure your user in your app has a certain WebView which you know all the features and all the problems with. But they have decided to stop that, so its time is obviously limited. All right, so here are some resources on the slides. I'm not going through those. The slides will be on SlideShare, so you can grab all those and go to the Quirks mode blog or look at other stuff. One interesting link here is the build WebView link, so you can actually build the WebView yourself from the Chromium sources, which is a really, really fun thing to do, which you should probably plan a weekend for. So, don't think it's easy, but it's actually really cool when you achieve that. With that, we've got like not much time left, so probably if you have questions, come and see me afterwards, either outside or next to the stage. Here are my contact details. Like I said, I'm really, really keen on feedback. Tweet me or send me a Telegram message. or send me an email if you like, whatever you prefer. The slides will be on this SlideShare URL in my account. And with that, thanks a lot for attending and listening, and I hope you got something out of, another view on the Webview. Thanks a lot.